I just finished watching the second get together for this group. So essentially, if you're not aware, this is a sort of club for researchers, people in academia, business owners, whatnot involved within not only the AI space as a whole, but also those who are trying to learn, how the brain actually functions, how do people learn, what are like what's basically the what's a granular level sort of view into how the brain actually operates, and is there anything we can take away from that and apply that to machines, right? And essentially right here you have a wide range of viewpoints that you can apply and basically figure out, what should the future of reinforcement learning, like what should that look like, right? And there's just like widely different aspects that you can go into. And what I'm going to try to do is basically break it down into about like 5 to 10 minute videos, and it's going to be a lot of information. But rather than making something that's probably going to be like 2.5, 3 hours that nobody's going to watch, I much rather put together like a 5, 10 minute video that's like way more digestible, and pretty much go from there, right? So basically, what I'm trying to get out of this is like what is a more efficient way of sort of making AI agents, making them smarter, faster, more capable, right? Because basically the general, how should I say, like the dominant sort of view in like the AI industry right now is scaling, right? So the general idea is the more compute that is being given, the more resources that you have, the smarter the model is going to be, right? And eventually you're going to get to a certain point where the model is, so amazing that, is basically indistinguishable, from a person, right? Now, when I hear something like that, like the first thing that kind of pops into my mind is that, it's very convenient that, these companies, Google, OpenAI, so on and so forth, right? The narrative is that, hey, just give us, billions and billions and hundreds of billions of dollars, right? And then you'll get, better and better models. And, just as long as you keep giving us, increasingly more amounts of money and more amounts of resources, then eventually we're going to reach, super intelligence or whatever the case may be. I think even if that was the case, which I don't really believe that is, even if that was the case, that just scaling was all you needed for something like that, the idea that you would get to like a genuinely intelligent machine, or like a fully autonomous machine, whatever you want to call it, the idea that you get to that point, and again you're just burning money, burning resources, burning all that. I just don't really see that as really a good way of achieving that at all, right? I think when you look at scientific advancements, with various different fields, right? Like if we're talking about like neuroscience, if we're talking about RNA design, aptamers, whatever, right? It's always, or not always, but many times it's either been like on accident, or it's been someone who was outside of basically their expected environment, and they're doing something completely unrelated to the original task. And as they're kind of walking, or just doing something again completely unrelated, even just sleeping, and they've been grinding away at this for maybe 5, 10, 20, 30, maybe even 50 years, right? And they finally clicks, it just kind of goes to show that the idea of learning, right, is not necessarily just a one-dimensional thing. The second point is that, I do agree with Eli on a lot of things. I will say though, one of my main points of contention would be that I don't think that there's really any analog, or not analog, excuse me, any sort of similarity between how a machine learns, right, and how a person learns, right? So basically, there's, for those who are unaware, there's basically an idea within the AI and ML space that essentially you can map one to one how the human mind works, and just sort of swap that in machine form, right? And by doing that, then you could reach fully autonomous agents, right? I think I mean, how should I put this, right? So I think because of the way that the main learning algorithm for machines, how it arose, how it was developed, it just kind of demonstrates to me that this is something like completely separate, and there's really not a whole lot of overlap between them. Like, so for example, right, um, very, very early on, I believe in like the late 80s, early 90s, there was essentially something called the LMS algorithm, which was like a very, very sort of like proto backpropagation algorithm, like not necessarily backpropagation, but at least like a fundamental component of how backpropagation works. And backpropagation is basically the main way that machines learn and how they are basically taking in information from a data set, right? And the way that backpropagation works is that there's really no, again, nothing else in nature or the world operates like it, right? Um, so again, whenever I see people who are saying things like not necessarily Eli, but just in general saying things like, oh, we've solved neuroscience and the brain is a token predictor. It just kind of feeds into the narrative even more. And again, it's one of those things where it's very convenient. Like, okay, so Transformers, the Transformers architecture, right? Which, um, in its very early stages, you could have said that it was a, token predictor or a concept predictor, whatever the case may be, right? It's very convenient that that was the architecture, back in 2017 with the attentions on knee paper, which sort of set off on the this path of Transformers, and then now you have people coming out and saying that, oh, they just magically woke up one day and they thought, and they know that neurosciences have been solved, and basically the brain is a token predictor, right? I kind of find that again, it's just one of those things where, people are trying to capitalize on, sort of the hype and the trend, and they're sort of feeding into um, these narratives, which really don't make a whole lot of sense, right? And the reason why I think that matters, and we should kind of, take a step back and really seek to make things more grounded, is because when I'm talking with researchers outside of the ML space, right? So like a biologist, a chemist, so on and so forth, they tell me like, hey, I've been hearing, all this stuff about LLMs and how, they're going to cure cancer and, they're this and they're that. They're going to do all these amazing things. And I tried it out for myself, and it's just like, it's completely underwhelming. You know what I mean? I mean, at one point, I believe ChatGPT 5, that was the model that was called like the Manhattan Project of our time. And again, when you say things like that, you have these massive, massive expectations, right? That it's going to be amazing, that it's going to, revolutionize, multiple fields. And then if it comes out, or excuse me, when it comes out and it doesn't really live up to the hype, then people, even if it is like a decent model overall, again, just because the expectations are so out of whack, it just really crashes the entire experience for a lot of people and really turns a lot of people off to the AI space as a whole, right? And before I kind of, really dived into the AI industry and I saw how it worked from the outside looking in, I didn't really understand why the technology got so much hate. Like outside of course, people losing their jobs and companies using it as an excuse to fire people, even though it's nowhere near the level that of like a fully autonomous agent. Like it's literally nowhere near that whatsoever. Again, companies are still using it as an excuse to lay off thousands of people, right? And again, I can understand, why people would hate it from that respect, but there are also other respects to where, like, even outside of just people losing their jobs to AI, there was just like this massive resistance towards it, right? And again, I understood, okay, that's one of the reasons why people hated it, but really there's also another aspect of AI where, basically it's almost like a scammy sort of, just overhyping and just, sucking in as much attention and money as possible. And you're just not really seeing the return on the investment, right? You have these headlines, right? That, you know, oh, this company spent $200 million on developing this new LLM, and they had hundreds of scientists and researchers and people sitting down and developing these algorithms and testing them and doing this and doing that. And then when the models come out, again, it's just not really what it was advertised, right? So again, that's why I'm, looking into this, sort of trying to sit down and make sense of all this information and pretty much go from there. So again, what I'm going to do is pretty much on the next video is going to be me diving into a paper specifically, and just going to be like one paper per video, and just basically trying to put together all of these pieces and make it into some type of coherent framework that could lead to a fully autonomous agent.